Last couple examples for section 10.3, we're going to be starting with the equations. We're asked to find the center, the vertices, the foci, the major and minor axis length of the given ellipse. So, wrong button. Goodness gracious, sorry. Let me make sure I don't do that again. Okay, didn't feel like starting the video over, so we're going to keep going. So one thing I want you to take a look at here is we have x plus 3 squared over 16 plus y minus 2 squared over 25. Now, the denominators can tell you about whether it's a vertical or horizontal axis. Take a look at which one's larger. In this case, the larger denominator is beneath the y part, so therefore we're dealing with a vertical major axis. So we've got a vertical major axis. Now the center is going to be one of the easier parts for us to identify. So let's start there. The center comes from the x and the y, what is being subtracted from them. So in this case, normally it's x minus h, and we got an x plus 3. So in other words, we're dealing with an opposite here. So our x coordinate of our center is going to be at negative 3. The y coordinate, we got y minus k, so it's y minus 2. K is 2. Not too bad. Now, I'm going to start drawing this as I go along. So we got a coordinate at negative 3, 1, 2, 3, up 2, and there is our center. Now, the rest of this, we're going to have to find our A's, B's, and also C's. So, using this, we've got these two values here. This is going to be our B squared, and this is going to be our, our A squared. Now, let me erase that because right now it looks like it's dividing it. So, we've got 16 is B squared, therefore B is 4. A squared is 25, so therefore A is 5. Nothing too complicated there. Now, to find the C value, that's going to help us find our foci. We're going to do C squared equals A squared minus B squared, still that thing that kind of resembles the Pythagorean theorem, but not quite. So we got C squared equals our A squared. Well, we already know what that is. That was the 25. We don't need to rewrite that whole thing. Minus the B squared, we know B squared was 16. So we got C squared equals 25 minus 16, which is just 9. Now we're going to take the square root of both sides of that. So we have C equals 3. Again, since we're dealing with distances, we're going to ignore the fact that it's technically positive and negative 3. We're just going to deal with 3. Now with that, that's going to help us find our foci. Since we have a vertical major axis, what we're going to end up doing is add and subtract 3 from the y coordinate. So we're going to leave the x coordinate alone, and let's just do plus 3. And if it helps you to visualize it as you're going up, if you just go up 3 tick marks and draw a focus, we're at the coordinate 3, 5. So there's one of our foci. And then, sorry, I switched colors on you, but that's okay. The other one's going to be 3 down, so it's going to be negative 3, comma, negative 1. Again, if it helps you to visualize it, just go 1, 2, 3 down, be here at another focus of 3, negative 1. Now our vertices. Our vertices are going to be the A distance away. Now, A in this case we found out being 5, so we're going to go 2 more up and 2 more down, because our focus points are 3 away, and so this is going to be a vertex, and we'll go 2 more down from our focus, and this is going to be another vertex. So our coordinates here are going to be at, negative 3, comma, let's just go for the lower one first, negative 3, and the higher one was at negative 3, comma, what are we up at? 7. Now the major axis length, that's just going to be 2 times A. So we got major, started writing axis before I was done with the first word. Major axis length is going to be 2 times A, that is 10. So going, and you can kind of see that on this graph here, going from this vertex up, you go up 10 tick marks. The minor axis length is going to be 2 times our B value, so it's going to be 2 times 4, so it's going to be 8. Now, since we have a nice, convenient minor axis in this case, as opposed to like the previous one, which was the square root of 15, that was annoying, let's actually draw it. So minor axis, that means we're going to go 4 tick marks over, and there's going to be the end of, it's going to be like the vertex of our minor axis. And same thing in the other direction. If we go 4 over, that'd be another minor vertex. This is where we are able to start drawing what this ellipse looks like. Now, of course, since we're freehanding it, mine's all wonky, especially because my scale's not great here. but hopefully it ends up being a decent shape. That's not my best, but we'll give it another shot later. All right, example 4, the last one. We're asked to find the vertices, or sorry, the center, the vertices, the foci, the major and minor axis length of the given ellipse. You'll notice that this one just looks a little different. We got x plus 2 squared plus y plus 4 squared over 1/4 equals 1. Couple things that are like a little odd here. The first part doesn't have a denominator. It's not set up as a fraction. Well, we can set it up as a fraction pretty easily just by putting it over 1. The second part is, well, this denominator is 1/4. That's kind of annoying. But now that we have them both as fractions, looking at that first fraction, we got x plus 1 squared over 1, and then the other one's y plus 4 squared over 1/4. It is a horizontal because the x group has the larger denominator. Horizontal, there we go. Now our center, again, it's what is being subtracted from the x and from the y. Well, in this case, you're adding in both cases, so it's the opposite. It's going to be a -2, -4. Let's take a second look at our a values. So this is the a squared, this is the b squared. Well, a in this case is just going to be 1. That's not too bad. Now b squared, let's think about this a little bit. B squared equals 1/4. To solve for b, we got to take the square root of both sides. We end up with b on the left side. On the right side, the square root of 1/4. Remember, taking the square root, or taking any root of a fraction, you take the root of the denominator and the numerator separately. So if I do the numerator, the square root of 1 is just 1. Square root of the denominator, square root of 4 is just 2. So our b value is 1/2. Now, we're going to use that to find our c value. We got c squared equals a squared minus b squared. Again, not the Pythagorean theorem, but really close. A squared, we already know that's 1. B squared, we already know that was originally 1/4. So we have c squared equals 1 minus 1/4. That's 3/4. Now, solving for c there, we take the square root of both sides, and it ends up being c equals, well, square root of 3/4 is not the nicest thing we've ever dealt with. So we got the square root of 3 on the top, and then our denominator, square root of 4, is just 2. So it's not the best, but it's also not the worst. Now, because we have a less convenient c value, that's going to affect our foci. I'm going to kind of show you a shortcut or kind of a structure to help you find any vertices and foci. So for our vertices, since it's a horizontal axis, we're changing the -2. We're going to add and subtract that, or that a value, that 1, from the -2. We're going to leave the y value alone. Now, since this is relatively nice, let's just write this out individually. -2 plus 1 is going to be -1, and then we're going to have -4. And then for the other one where we subtract 1, it's going to be -3, -4. Again, the reason we're doing this is because, well, the next one's not going to be as nice for the foci. Again, it's going to be -2 plus and minus that square, sorry, I'm getting ahead of myself. No, that was right. The square root of 3/2, that's c value. So to go from the center to the foci, you add and subtract the c value to, well, in this case, to the x value. Now again, this one's not super nice, so if you do want to write them separately, it'd be -2 plus the square root of 3/2, comma -4, and then the other one would be -2 minus the square root of 3/2, comma -4. Those are not the nicest ones to deal with, but that's okay. All right, just making sure we've done this. We got the center, we got the vertices, we got the foci. Now we're going to do the major and minor axis length. So we got major axis, that's just going to be 2 times a. So that'd be 2 times 1, so it's just, well, 2. Again, that comes from 2a. Our minor axis length is going to be 2 times our b value. Our b value ended up being 1/2, so it's 2 times 1/2, which is just 1. So we found our major and minor axis lengths as well.